Hello, and I just wanted to help you be able to keep on going with these things. This is Workbook 24.1. I'm going to do a quick lesson, and then I'm going to actually do the workbook with you. So triangle proportionality is all about making proportions from triangles. And so you might have two triangles that are split up with a parallel line. So we have this triangle here and the bigger triangle there. And the main thing that you have to know, and this includes the discussion, is we are looking for proportions. A really short and simple way, it's not as easy to see every time, but to describe what proportions mean is if we knew the length of one of these, then to get the other one, we would have to multiply it by the same number. So if I knew how long this was, then I knew how long that was, I could figure out what I have to multiply this segment by to get to that segment. Or down, and then you would have to be that same number. If I knew what this one was, I'd have to be the same number to get to that one. Or if I knew this one up here, this segment up here, I could get that one down there by dividing. So it's all about proportions, which means multiplying by the same multiplier. Another way of looking at it is you can set up proportions, which are the two fractions that equal each other. So here we have this example right here, and it looks super complicated. We have these three lines that are all parallel. And then it tells us that this part's 4, this whole thing is 12, this little part right there is 4.5, and that little part right there is 3. And what it asks us to do is to find that part right there. And this is all about proportions and multiplying by the same thing. So I'm just going to just briefly tell you what I would do to solve it. So I know that that part's 3 and that part's 4.5. That means in order to get from 3 to 4.5, I would have to multiply that by 1.5. And maybe you can't see that or you can't do that work in your head, but 3 times by 1.5 is 4.5. So 4 times by 1.5. So let's see, 4 times 1.5 is 4 plus half of 4. Half of 4 is 2. So that means that side right there is 6. She explains this in this video. I just want to give a plug for her. This video is actually pretty good. She explains it in a different way though, and there are really good ways of explaining it. So same thing with this one. If we know that this is 3.2 and that's 4.8, I personally cannot do that math in my head. So I would need to set up a proportion. So I'm going to show you how I would set up the proportion. So then here I have the same triangle that I just drew in this other thing, but I wanted to show you how I would do it. So I think that putting the sides there is really nice, but this is the honest, like how I would do it. So I'm going to make fractions that kind of look like what's right here already. So notice I want to find this part right here. Let me pause and make sure. Yep, that's what we want to find. So I have these proportions that are kind of already set up. So there's one fraction and then there's the other fraction. So I could have the thing I want, which is Kp over 4.8 is equal to 4 over 3.2. So now I can solve that proportion. One thing I talked about in another video, if you didn't watch it, it's okay, is if this is the thing that you want to solve, then you can use Maui's hook from Moana to solve it. Because technically what you would be doing is you would be doing 3.2 times by Kp is equal to 4 times 4.8. And so what we're going to do now is just solve. And so we would divide both sides by 3.2, divide both sides by 3.2. So what we do in the end is we would do 4.8 times by 4. So that's this diagonal part of the hook. And then divide it by the other one, divided by 3.2. Then you can get a calculator, such as Desmo's. And then do 4.8 times 4 divided by 3.2, and we get 6. So just coming back to this assignment, so we come back here and we can just type in 6 and submit, and it is correct. So that's the idea. I'm going to go down to the homework now. So they have all these proofs, so use the diagram and information to complete the proof. So this is all about doing similar triangles. So they went through here and they said that BD, let's look at what they said. They talked about BD plus DA is equal to BA, and BE plus EC is equal to BC, and this is just I'm supposed to, segment addition, because you're just adding them, right? It's kind of easy because you just add them. Then down here to number 7, and we have these proportions which come from this one. So we replaced the top parts of these proportions with the addition there. So that was substitution that we did. And then now we split it up into, so that both of these things were divided by BD and both of those things were divided by, BD and BE. So that is expansion of fractions. And then you can see that BD divided by BD is 1. So that was simplifying of fractions. It's just simplifying the fraction. Oh, I guess that is just division, right? And then we can subtract both things, something from both sides, because we subtracted the 1. And then when you subtract the 1, then that means this part is the same. So that would be the reciprocals of both sides. Yep, that's what it is, reciprocals of both sides. So there you go. So there's question 1. And then question 2, examine this figure and find A. So again, this is where I'm going to use the thing I did on the other one. So I'm going to set up the proportion. So I'm going to use these two fractions because they already kind of look like fractions. So I'm going to do 18 over 36 is equal to A over 42. So let me show you how that looks. Right there. That's an A. It looks like a 9. A over 42. So then here's the hook right here. So it'd be 42 times by 18 divided by 36. So I can go to Desmos, 42, 18, 36. So 42 times by 18 divided by 36, and we get 21. So coming back here, we get this, and we got 21. Right. Voila. Okay, so that was 24.1.